All right, section 3.1 is talking about complex numbers. So we had a conversation earlier about the real number system, and that was our first section in chapter 1, and that talked about natural numbers, whole numbers, integers, rational and irrational numbers. And I mentioned then that there was another number system, and that is what we're talking about today. That's the complex number system. All right, if I were to graph a complex number, it would not go through the x-axis. There are no solutions to that. All right, and so what a complex number is using the imaginary letter I. So I stands for the square root of -1. So this is what has helped us be able to go further in our mathematics is when we, things continually to evolve, and that's what mathematics does. And so that's what this has helped us be able to do. So, originally we could say that the square root of 9 is 3 because it's 3 times 3. But we could not then say, well, what's the square root of -9? Well, 3 times 3 wouldn't work, and -3 times -3 wouldn't work. So there was no solution to that. Well, now there is, because we know that -1 is equal to an I. And so complex numbers are not, they may not be used in everyday life or something that you do, but it's important to be introduced to them so you are aware of them. They're used probably in, dealing with waves, the trigonometry and waves. So things with like light and electricity and sound and radar signals, things that include those waves are where you might see complex numbers used. There are some in like quantum mechanics, even in some gaming, first of all, because you're dealing with some of the sound, so they could be involved with gaming, or there's something called quaternions, and those are things that represent like an orientation or rotation of 3D objects, and that's sometimes used in gaming, that type of programming. So, it is used out there. It's used out there for vectors that are showing direction. So, there are places that it's used, but some of you may not ever see these again. But it's good to know what they are and that they are around, and they are part of mathematics. So, so let's talk a little bit about, so if I have the square root of -9, so what that is going to be is, I know that this is the same thing, right, and I could write it like this if I want to. Could break it apart. All right, so we know that this is 3, and we know that this is I. So how you want to write that, you want to put your coefficient number, your real number first before you write that imaginary number. So that would be 3i. So if I had something like square root of -25, well, 5 times 5, and then this comes out to be an I, so that's going to be 5i. So I can now do these radicals that have negatives under them. All right, so I'm going to come back to talking about this a little bit more in just a second. And this is something I just want to introduce you to, the powers of I. So if I have something that is I squared, okay? So I squared. Now let me ask you this. If I said, okay, so if I said, what is the square root of 2 times the square root of 2? Well, that's the square root of 4, but your answer actually is simplified down to 2. Okay, what about the square root of 3 times the square root of 3? Well, that's square root of 9. That comes out to be 3. So do you see the pattern? If I take a square root of 12 times the square root of 12, what's that going to be? It's going to be 12. So whenever I take a number times itself under a radical, it always comes out to be that number. Well, that's the same thing here. So we know that I is square root of -1. So this is going to be square root of -1 times square root of -1, because that's I times I, and that's I squared. So what's that going to be? That's going to equal a -1 just like we did here. When I multiply a number times itself, it comes out to be that number. And an error students make is they just try and multiply that and make it a positive 1. But that's not how this works with our radicals. Okay, so anytime we have an I squared, that's what this means, and it's always going to be a negative 1. So if I have something that is, I'm simplifying something that's 2i squared, that's going to be 2 times a negative 1. And that's going to equal a negative 2. So anytime I have an I squared, I replace it with a negative 1 because that's what it is. And then I can simplify from there. Now there's something about powers. I'm going to do this on the back of this page. So if I have I squared, first of all, we have I, and that equals square root of negative 1. And then I squared is going to be negative square root of 1 times square root of negative 1, right? And that equals negative 1. Okay, what about I to the third? Well, that's going to be square root of negative 1 times square root of negative 1 times square root of negative 1. Well, we know that this, right, this equals a negative 1. So this times this equals a negative 1. And what's the square root of negative 1? It's an I. So this equals I. So this is going to equal a negative 1i, or I could also just write it as negative I. That 1's always there. You don't have to show it. So let's think about I to the fourth. So it's 4 of these. So we know that 2 of them equals a negative 1. So multiply these together, we get a negative 1. Times, we multiply these together, we get a negative 1. So what is that going to equal? That equals a positive 1. Now, just to show you this, so I want to go I to the fifth. So we're going to do 5 of these. So here, let's figure this out. So here is a negative 1. Here is a negative 1. Here is just the negative 1. So that's just going to be I. So negative 1 times negative 1 is a positive 1 times I is 1i, which we don't show the 1. And I'm going to do one more. This is the last one we're going to do. I'll get it up here so you can see it. Let me move my computer. There we go. All right, so this becomes a negative 1 times negative 1 times a negative 1. So what is that? Negative 1 times negative 1 is positive 1 times a negative 1 is an excuse me, sorry about that, is a negative 1. So what I want you to see is when I do these first 4, okay, I have an I, all right, so that's I, negative 1, negative I, 1. Now what's happening? I, negative 1, it's a repeating pattern. After I get these first 4, it continues to repeat. So if I wanted to know what I to the 7th was, well, if I look at the pattern, we have I, negative 1, negative I, 1. I, negative 1, so what would the next one in the pattern be? A negative I. And then what would I to the 8th then be? Okay, so then what would I to the 8th? Well, in the pattern, right, we're going to end up right here at 1 equals 1. So one way that I kind of show that is because what if I said, well, what is I to the 200th? You know, it would take a long time to keep writing that pattern, correct? So if you just put it together in this little chart here, and so we began with I, that was our first one, and then our second one was negative 1. Okay, so we're going to put a negative 1 here. We're going to go around clockwise. And then we have a negative I and then 1. So then a negative I and then 1. And then the pattern starts to repeat. So this is I to the first, second, third, fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth. So I could just count around unless I have a huge number like 200, right? So it repeats after every 4. So if I take a number like I to the 182nd, Okay, all I need to do is take this power and divide it by 4. And that tells me how many full 4 rotations I'm going to end here. Like here's 1, here's 2. How many of those? So if I take 182 divided by 4, let's see what that is. That's 4, let's see. So that's 16, 22. So that's, maybe I should show it to you this way so you see it. So 4 is 16, 22, 5, right? And that's 20. So we have a remainder of 2. So this is 45, remainder 2. So that just means we do 45 full rotations of 4. So we don't really worry about that. We went through 45 times. But then we end here after the 45th, right? Because that's after the 4th. Now we got to go 2 more. So we go 1, 2. So I to the 182 is going to equal a negative I. So let's try another one. Let's say I to the 37th. So we always divide by 4 because the pattern is 4. So we're going to take 37 and we'll divide it by 4. Well, 4 goes into there 9 times, which is 36 with a remainder of 1. So 9 remainder 1. So we go 9 times all the way, 4 rotations. We end here. Remember, you always end here. And then we have 1 more because we have a remainder of 1. So we go 1 more. So it's I. That's what it would be simplified. All right. So that's something you can work on and practice. We don't do a whole lot. We don't go much higher than I squared when we're working with quadratics. But I think it's good to have seen that and know how to, and I might ask you on a test, tell me what I to the, whatever, 222 is. And you can simplify that for me. All right, so let's move on down here to just continue to simplifying from where we kind of started up here. So square root of negative 121. Well, this is a perfect square and it's 11, right? And so this is our I. So this just comes out to be 11I. All right, now this one is not a perfect square. So I want to figure out, well, what can I do to make, is there a perfect square in 28? So when we break down that radical, we have an I, right? So we have that negative, I'll just leave it there. And then we have, how about 4 times 7? That gives us a perfect square. So this is a perfect square. So I can, what is the square root of 4? Well, it's 2. So for this, I can bring out a 2. And then for this, I can bring out an I. So we have 2I on the outside, but this has to stay. So we're still left with a radical 7. Now I'm hoping in your last class you worked on breaking down radicals a little bit. If you didn't, then let me know. We can do some practice on that, but you really need to be able to break down a radical, okay? And that's just doing this, finding perfect squares in it, or you can break it down to prime numbers. And then if you have 2 of that same prime number, you can pull it out. Like if I broke this down, this could also be broken down to a negative, and then 2 times 2 times 7. That's all prime numbers. That's what I mean. And then if you have 2 of the same number, since it's a square root, which is 2, you can bring a 2 outside. And then you have this I, and then you're left with 7 underneath and get the same answer. All right, so you can break it down to prime numbers. And then if you have 2 of them, bring it out. All right, so here's multiplication. So multiplication is just multiplying your coefficient and whatever number that is. So 5 times 2, that's going to equal 10i. Okay, looking at this one, negative 3 times 2 is a negative 6. And then what is I times I? It's like taking x times x. So that's I squared. When we multiply variables, we add their powers, and those are both a 1, so it's I squared. Now this is never simplified if you have an I power greater than 1. So what did we learn that I squared is? We come back up here, I squared is equal to a negative 1. And that's the most important thing you need to remember on that. So that's the same thing as saying a negative 6. We will replace the I squared with a negative 1, and we're left with positive 6. Okay, you have to completely simplify that down. All right. Let me see if I can get a little more light over here. I know it's kind of, see if this helps. I don't know if it does or not, but we'll see. Maybe a little bit, not too much. Okay, I guess that's not going to help too much. All right, so let's look here at adding. So when we add and subtract, this is the complex form that you want to finish writing all of your answers in right here. And what this is saying is A is a real number, just like 5, 10, whatever the number is. And this is your imaginary number. And your imaginary number is always written last. Okay, that's important. You have to write it in order. So you have your real number plus or minus your imaginary number. And that's how you write your final number when you're done. So when we think about this adding, so this is just adding together. So what is a -2 plus 1? Well, it's a -1. And then we have 5i plus a -7i, which would be a -2i. So I put the whole number and then the imaginary number last. And that's how they're always written, is like this. So be sure you do that correctly. You'll lose points on a test for not doing that. All right, so subtracting. So the only difference with subtracting is when we have a subtraction here, we're going to distribute that through. And so let's just rewrite it as 4 plus 6i. And then this becomes a -1. If I distribute that negative through, so that becomes a +1. And then we'll do it here, and then we'll distribute it here. So a -2i. We're multiplying through by -1. Okay, now let's combine our whole numbers first. So 4 plus 1, we have 5. And then 6i minus 2i plus 4i. So notice we're not multiplying those. We're just adding them or subtracting them. Just like it were in X, it's the same thing. All right, so now let's look at multiplying. This is a little bit different. We still write the answers the same way. Okay, we're still going to do the answers the same way. And then, just trying to get that light to be a little bit brighter here. All right, so here we're going to use, just like you multiply any other binomials, you can use FOIL, distribute, stack, box method, any method that you want. All right, hopefully you learned a few different ways to multiply those, but you do whatever you know how to do and whatever's easiest for you. I'm good with that. All right, so we're going to distribute the 2 through first. So 2 times 9, 18, and 2 times a -3i. So 2 times a -3i, -6i. 4i times 9 is 36i. And then 4i times a -3i. So 4 times a -3 is a -12. And then I times I, this is not adding, I times I is I squared. All right, so let's rewrite this. So it's 18 minus 6i. Okay, so this becomes what? That becomes a -1. So that's going to be minus 12 times a -1. So I can replace that. So here we have 18, and this becomes a +12, right? -12 times a -1 is a +12. So 18 and 12 will give us 30. And then a minus 6i and a positive 36i would be plus 30i. So notice the form: real number, imaginary number. All right, now if you want to pause it and you want to try doing this one, go ahead and do that. I'm going to go ahead and show you the answer now, but you can pause it, practice it, and see how you do. So let's use FOIL on this one. So we'll do our first terms. Okay, so 3 times 1. And then we'll do our outside terms, -6i times 1. We'll do our inside terms, 4i times 3. And then we'll do our last terms, 4 times a -6, -24, I times I squared. So I'm just going to rewrite so you see this. So 3 minus 6i plus 12i minus 24, and in place of the I squared, I'm going to put a -1. All right, so this becomes a positive 24. So 24 plus 3 is 27, and then -6i plus 12i is plus 6i. All right, lastly, let's do the division of complex numbers. So this division is when we use what is called a complex conjugate. And I use the word conjugate quite a bit when we talk about that. And what a conjugate does is it helps you, so we can never have a fraction with an imaginary number in the denominator. So that is our goal, is to get rid of that. And how we do it is we use what's called the conjugate. And it's really about just taking the opposite sign of the imaginary number that you have. All right, so that's pretty much what the conjugate is. So what I'm going to do is I'm going to multiply this times the opposite of this, which would be a negative I. All right, and then, but what I do to the denominator, I also have to do to the numerator. I'm going to put that in parentheses so it looks like I'm multiplying, not a subtraction. All right, so I multiplied the bottom and I multiplied the top. So let's go ahead and distribute this negative I through. So this times this gives us a negative 2I. 3I times a negative I is going to be a negative 3I squared. 3I times a negative I, it's a multiplication. Okay, and we'll simplify that here in just a minute. So let's do the bottom. What's I times a negative I? Negative I squared. So what we're going to do then is we're going to replace these I squareds with a negative 1, because that's how we simplify an I squared. And if I just have an I left, then that's okay. I can have an I left in my answer, but I can't have anything higher than a power of 1. So down here we have a negative, and then I squared is a negative 1. So this becomes a negative 2I, negative times a negative, plus 3 over 1, which is really a negative 2I plus 3. Okay. All right, so let's take a look at this conjugate. So this conjugate, because it has, this one only had an imaginary, this has a real and an imaginary. So when I said you just change the sign of the imaginary number, so we leave the 1, and then this becomes a minus 2I. That's the conjugate. That's what I'm talking about when I say the conjugate. And then I have to also multiply it times the top. You have to do the numerator and the denominator the same, okay? So here we multiply 8 times 1, and then here we have 8 times a negative 2I, which is a negative 16I. And then on the bottom, we have, if you want to put parentheses around this, you can if it helps a little bit. Sometimes it's easier to see it that way. It's up to you. 1 times 1, 1 times a negative 2I, I'm just multiplying through, 2I times 1, and then 2I times a negative 2I would be a negative 4I squared. And the nice thing about the conjugate is these numbers are always, always, always going to be opposites and cancel out. So they're always going to drop out, and that's always going to happen, okay? So on the top, we're left with an 8 minus 16I. And then down here, we have 1 minus 4, and then in the place of the I squared, we put a negative 1. So we're left with 8 minus 16I. This becomes a positive 4 over 5. And then let's do one more. If you want to pause it and go ahead and do this one, go ahead and come back here. So let's do the conjugate. So the conjugate is going to be 1, and it's always the denominator. 1, change the sign, so plus I, and then 1 plus I. Okay. So let's distribute. So 2 times 1, 2 times I times 1, which is 1I, and I times I would be I squared. Okay, now this is not going to cancel out because this is not the conjugate up on top, it's on the bottom. So what do we have left here? So this is going to be, we're going to replace this with a negative 1. So 2 minus 1 is 1, so we end up here with 1 plus 3I on the top. Okay, now let's look at the bottom. On the bottom we have 1. Now what's going to happen? Minus 1I plus 1I. And I'll put them on there, but I just want you to see. So plus I minus I squared. Okay, so this becomes a negative 1. So we're going to have 1 plus 3I over 1. This is minus a negative 1, so that becomes a plus 1, right? All of that is a plus 1. So 1 plus 1 is 2, and then this is gone. That drops out. So here's your answer, 1 plus 3I over 2. Because this is minus I squared, so minus a negative 1. If you can read my writing there. Okay. All right. So that's conjugates and dividing complex numbers. So that's the lesson on complex. Hope that helps you out with your lesson. And I hope you guys have a great day. Thanks.